Hello, Curran here. This video is about cheap tricks for interaction with D3 and SVG. This is the interactive map that we'll create. First, we're going to add this highlighting here with just CSS on hover. And if you stop for a little bit, you can see this tooltip comes up that shows the country name when you hover. And also, you can zoom in on this map and see more details. If you followed the Let's Make a Map lecture and you're interested in adding simple interactions to existing visualizations with little effort, then this video is for you. I say cheap tricks not necessarily in a bad way, but because these tricks give you the most bang for your buck, so to speak. You can put in a little bit of effort and get a big result in terms of interaction. And these three methods I find to be the easiest ones to add, but also some of the most useful and impressive. Like if you show it to somebody, they're going to be like, wow, that's cool. So that's why I called this video Cheap Tricks for Interaction, because it takes little effort, but you get a lot of bang for your buck in terms of your effort. The topics we're going to cover here include highlighting on hover using CSS, adding simple tooltips using the title tag, and doing this for the case of the map takes us on somewhat of a diversion, which includes loading multiple data files and also looking up a country name based on its ID. And finally, we'll also cover adding panning and zooming to the map. I'll start by forking this Let's Make a Map example, and then I'll rename it to Cheap Tricks for Interaction. One of the easiest interactions you can add, and you can just do it in CSS, is that when you hover over one of these countries, it should turn another color. To do that, we can select on .country : hover, and then in here, we just set the fill to be some other color, like maybe red. Now, if you hover over these countries, they turn red. Another cheap trick we can do is so that when you hover over one of these countries, its name pops up as a tooltip. We can do this with the title attribute. So over in our index.js, I'm going to add a new attribute to our country paths. I'm going to say .attr title is, let's just say hello for now. And then if I hover over a shape, oops, this is not working. This works for other HTML elements, but I just remembered that in SVG you need to actually add a child element that is a title element itself. And before I forget, I'm just going to clean up this README, delete that. So what we need to do instead is we need to append title elements as children of the path elements. So after we append the path, we can append here a new element called title, and then we can set the text content of that element to be hello, just to see if it works. Now if I hover over a country, it says hello. But we want this to be the country name, so we can make the text a function of D, and this should return D dot something, but I don't remember what the properties are on D. So right here, I'm just gonna say console.log D, and then see what these properties are. So we've got our D objects here. So we should be able to access D dot, well, ID is there. And I was hoping the country name would be here in the properties, but unfortunately it's not. But we have this ID that I think we can use to look up the country name. We're fetching this topo.json file from this URL here in unpackage, and I believe there's another data table in here, and we can check that by copying this URL here, and notice how it ends with a trailing slash. That should give us a directory listing of what's there on unpackage. And see here, there's a TSV file, a tab separated value file, and let's see what's inside of here. This has a bunch of attributes about each entry, each country. And I think one of these here should be the ID that we have in the GeoJSON, one of these columns. After some digging in the World Atlas project, I found that the ID corresponds to the ISO_N3 field of that TSV file. This gives us enough information to get from this ID to the country name, but we need to load in this TSV file in our code as well. D3 has a nice utility for fetching and parsing TSV files, tab separated value files, which is just called TSV. So we can import TSV as well from D3. And then we can load the file like this, TSV, and we pass in the URL, which I'm just going to copy from here. The URL is just the same as the JSON, but just .tsv instead. And then this returns a promise, so I'm going to call .then and pass a callback that accepts the data, and I'm just going to say console.log this data to see what it is, see if it worked. But first I'm going to comment out this here that logs some other stuff to the console just so we can see this clearly. Okay, it looks like it worked. 177 rows, and they look each something like this. And brk_name looks like it has the human readable country name. Or, I don't know, it looks like there's a couple different properties that have the country name. Name looks good. That looks pretty official. So I'll just make a note of that for later. Use d.name for the label, and we need to use d.iso_n3 for the ID to look it up. I'm just going to make a note of that as well. What we need to do here, though, is load both of these files and have both of these data values in the same scope. To do that, we can use promise.all. This is a great utility that executes multiple promises in parallel and then returns a promise that resolves only when all of these promises are resolved. So the way we can use this is we can pass in an array, and the first element will be the promise that fetches the TSV file, and the second element will be the promise that fetches the JSON file. And then on here we can say .then, and this resolves to an array of values. I'll call the first one TSV data and the second one topo JSON data. And this is, by the way, ES6 destructuring syntax. In the body of this function here, I'm just going to console.log both of these just to make sure that this code worked. So we can say console.log TSV data and also console.log topo.json data. So let's see if this worked. It looks like it did. See, we have this array and this object. This is the TSV, this is the topo.json. All right, now we can move this logic that renders the map into this callback here. And I'll fix the indentation. And this is referring to data, but we have renamed it here to topo.json data. So I'm just going to use that here instead. Coming back to the text of our title element, what should we use here? If I remember correctly, we had d.id available. So let me just check that. d.id, if we put that there in the console.log, what do we see? Okay, great. These are the ID values. And what we want to do is look up the country name based on that ID. So we can say country name at d.id. See, I'm imagining that we can create an object where the keys are the IDs and the values are the country names. So let's do that. Let's create this variable, const country name. It's going to be an object, an empty object at first. And then we can loop through this TSV data by saying tsv data.forEach. And we pass a function here that takes as input one row of this table. And now we can use our notes from earlier about what to use. And this is dead code, so I'm going to delete that. But in here, we can use d.iso_n3 as the key. So we can say country name at the key d.iso_n3 equals the name of the country, which is d.name. So that should work for constructing our lookup table of IDs to names for the countries. And if we open up the DevTools, we see that indeed it looks like it's working. Remember, what's getting logged out here is country name at d.id. Now all we need to do to make the tooltips work is to return that value instead of logging it out. So if I just get rid of that console.log, and now if I hover over a country, it says, all right, that's Brazil. Sweet. By the way, this is such a common pattern that you'll encounter a lot, and there's actually sort of a cleaner representation for this using reduce. So now that we're at this junction and we have this here, I just want to show you what this looks like to use reduce instead of for each. So I'm going to comment out this part, and we can formulate it differently. We can say const country name equals tsv data.reduce. And this is a functional programming thing. It's built into JavaScript arrays just like for each. The first argument to reduce is a function, and that function takes as input two arguments. The first one is the accumulator, so I'll call that accumulator. This is the thing that ultimately gets returned by reduce. And the second argument to this function is going to be what we think of normally as D, the row, so I'm going to call it D by convention. And then the second argument to reduce is the initial value of the accumulator, which in this case will be an empty object. And in the body of this function here, see, I'm going to expand these curly braces so we can have a function body here. This is where we can say, we can have this logic here, but instead of country name, this is going to be our accumulator. Accumulator at this key is this value. And then we need to return the accumulator. And this is exactly equivalent in terms of functionality to this logic down here. See, the tooltips are working again. Just to review how reduce works is that the second argument is the initial value for the accumulator, which gets passed in as the first argument here for the first row, which is D. And then we say, all right, set this key, the ID, to the name of the country for this row, and then return the accumulator from this function, and then the returned accumulator is passed in as the first argument the second time this function gets invoked for the second row. And so each time we're just adding more and more keys to this accumulator, and then the final returned accumulator gets returned from reduce, and that gets assigned to country name. And I kind of prefer this formulation because we don't need to have this explicit mutation inside of for each. It's a more clean functional approach. So anyway, that's how you can use reduce to accumulate many keys on one object for use as a lookup table. The final cheap trick I want to add here is panning and zooming on this map. For this, we can use the D3 zoom package. This is also part of the default D3 bundle. And I always like to just consult these reference examples to see how it's used. See, the first link uses canvas. I can tell because it's a little blurry. The second link uses SVG. So this is what we're going to use as our reference example. We need to access D3.zoom. So in our code here, let's import zoom from D3. So import zoom as well. The way D3 zoom works is that it's a function that gets called and you pass in a selection on an SVG element that will receive events, mouse events like the scrolling and the panning, with the clicking. So in this example, a rectangle is being appended that doesn't have any fill, it's invisible, but it gets all the pointer events. And so I think we need something like this as well. But if I recall correctly, you can just use the SVG element itself. Let me just try that. Let's try adding zoom right here. We can say svg.call, and we can pass in a new instance of d3.zoom. We can just say zoom and call that as a function. And this is the formulation here to listen for the zoom events. So on the instance of d3.zoom, you can call .onZoom and pass it some function. So I'll paste that logic there, and I'll change the quotes to be consistent. And instead of having this function zoomed, I'm just going to define a callback function right here. And what I'm looking for is that this function gets invoked when we're supposed to be zooming. So I'm just going to say console.log zoom. So if I open the console here and I use the scroll wheel, all right, it says zoom. And if I'm off the map, it also works. All right, sweet. So it looks like we don't really need that invisible rectangle. After all, we can just use the SVG element. Let's see what that original zoomed callback was doing in the example. This is all that it does. It says g.attr_transform is d3.event.transform. It's like magic. And that's all we need as well. So let me just get more space there. And we can do the same. I'm just going to paste that same logic, change the quotes. And using d3.event is inconsistent with the way that we're doing things, so instead I'm going to import event from D3 as well. And that line's getting a bit long. I think I'll just reformat that import statement. The idea here is that event.transform is set to, what the zoom transform should be, which does some scaling and translation on the group element that contains all of our marks, all of our polygons here, but we don't have a group element defined yet. So let's define G. We can say const G equals svg.append G. And for this to work, we need to append our shapes to G rather than SVG. So down below, instead of svg.selectAll, I'm just going to say g.selectAll path. And now, if we go to our map, it has panning and zooming, but oh no, the background doesn't. What's going on there? I think that might be attached. There it is. It's attached to the SVG, not the G. So I'm just going to rearrange this so that we define G before that logic, and then we append that sphere path to G instead of SVG. Now, boom, everything's working. We've got a full-fledged interactive map with hovering and tooltips. Now that zooming is working, it's very noticeable that we have some sort of deficiency in the way that we're doing the lines there. So let's take a look at how those lines are being filled in. This is the CSS here that is responsible for those lines. And see, the stroke is black and the stroke opacity is 0.1. So what's happening is I think the stroke from one country is overlapping with the stroke from the other country, but just in certain cases where one is behind the other. So we're getting this weird effect. I think the solution here is not to use stroke opacity, but now we've got these really thick black borders when we zoom in. So what we can do is set the stroke width. We can set stroke width to be, say, less than 1 pixel, like 0.5 pixels. And now they're not as thick. Let's try to set it really, really thin. What if it's like 0.05 pixels? Now when we zoom in, the borders look, pretty much reasonable. And when we zoom out, they look pretty much the same as they did before. They're kind of faint. This is because of how SVG rendering works. It does anti-aliasing. So even though it's less than 1 pixel, they still appear. So now we have something that you can actually use to test your knowledge of geography. Like, what's that country there? I don't even know. Oh, that's part of Russia, Lithuania, Latvia. And by the way, now that we're zooming in, it's clear that these are sort of very simplified shapes. And that's because we're loading the topo.json for 110 meter resolution. But if we just change this number from 110 to 50, and I'll do the same for the TSV. Now, if we zoom in, let's take a closer look. See, it's much more detailed. Everything is much more detailed. So I think it's worth using the more detailed shapes once that we have zooming working. And the zooming is still pretty smooth, so it didn't really impact performance that much. Now that we have more detail, it makes it more interesting to zoom into certain parts of the world where the terrain is like super detailed, like over here in Indonesia, or over here, up here in Canada, or, well, Alaska, I guess. See that? That's pretty cool. That's all for cheap tricks for interaction with D3 and SVG. Why don't you try some of these techniques on some of your visualizations? It could work for a bar chart, scatter plot, a lot of things. You can add these techniques and it will work pretty well. So good luck, and thanks for watching. Take care.